Good day, everyone. I am Jasame Sparsha and I will be your teacher for today. And in this video presentation, I will discuss some of the fundamental concepts in linear algebra. These concepts are very important in mathematics and are widely applied in fields such as engineering, physics, computer science, and artificial intelligence, robotics, and data science. The topics that I will be discussed are the dot product, angle between two vectors, cross product, linear algebra, linearly dependent, linearly independent, spanning set, bases, and dimensions. They also provide these concepts are essential because they help us understand about vector spaces and the relationships between vectors. They also provide the foundation for many advanced mathematical topics and especially in applying in real-world problems. So, before discussing the different concepts, let us first understand what vectors are. So, a vectors is a mathematical quantity that has both magnitude and direction. So, to give you the definition about the magnitude, it refers to the size or length of the vector. While direction tells where the vector points in space, this makes vectors different from scalar quantities, which only have magnitude and no direction. For example, distance is considered a scalar quantity because because it only tells how far an object travels. On the other hand, velocity is considered a vector quantity because it describes both speed and direction. So now, vectors are usually represented using arrows or component notation. For example, a vector written as angle bracket 2, 3 means that the vector moves 2 units horizontally along the x-axis and 3 units vertically along the y-axis. Vectors are important in many areas of mathematics and science because they are used to represent quantities such as force, movement, acceleration, displacement, and direction. So, understanding vectors is very important because the concept that we will discuss later are all based on vector operations and vector spaces. The first concept that I will discuss is all about dot product. So, the definition, the dot product is an operation between two vectors that produces a scalar value. So, to compute the dot product, we multiply the corresponding components of the vectors and then add the product together. For example, if vector is a single bracket 1, 2, 3, and vector b is a single bracket 4, 5, 6, we multiply only by 4, 2 by 5, and 3 by 6. After adding the products together, the result is 32. The dot product is useful because it helps determine the relationship between two vectors. It can tell us whether vectors point in similar directions, opposite directions, or are perpendicular to each other. If the dot product is positive, the vectors generally point in the same direction. If the dot product is negative, the vectors point in opposite directions. And if the dot product is equal to 0, the vectors are perpendicular or orthogonal. The dot product is widely used in physics, engineering, computer graphics, and machine learning. It is also important because it is used in finding the angle between vectors, which is our next topic. So, our next topic, as I said, is about angle between two vectors. So, the angle between two vectors describes how closely two vectors point in the same directions. So, to determine the angle, we use the formula involving the dot product and the magnitude of the vectors. The magnitude of the vectors of a vector refers to its length. If the angle between two vectors is 0 degrees, the vectors point exactly in the same direction. If the angle is 90 degrees, the vectors are perpendicular or orthogonal. If the angle is 180 degrees, the vectors point in opposite directions. So, using the angle between two vectors is important because it helps determine directional relationships. The concept is widely applied in the navigation, robotics, computer graphics, physics, and even machine learning. So, for example, in machine learning and data science, the angle between vectors can be used to measure similarity between data. Smaller angles indicate greater similarity, and the larger angles indicate the less similarity. So, the next topic, that would be the cross product. Unlike the dot product, which produces a scalar value, the cross product produces another vector. So I want you to take note of that word, that the dot product produces scalar value, but this cross product produces another vector. So the cross product is defined only in three-dimensional space. The resulting vector produced by the cross product is perpendicular to both original vectors. And one important property of the cross product is that its magnitude represents the area of the parallelogram formed by the two vectors. The direction of the resulting vector is determined using the right-hand value. Because in the right-hand value, the fingers point in the direction of the first vector and curl toward the second vector, while um, the thumb points in the direction of the resulting vector. So the cross product is commonly used in physics, engineering, especially in the topics involving rational motion, torque, magnetic force, and um, three-dimensional topics or graphics rather. It is also very useful in computer graphics because it helps determine the surface orientation and the lighting effects in three-dimensional um, models. Okay, to proceed, our next concept would be the linear combination. So, a linear combination is formed by multiplying vectors by scalars and then adding the results together. Scalars are ordinary numbers used to scale or resize vectors. For example, if we multiply one vector by 2 and another vector by 3, then add them together, the result is called the linear combination. So linear combination are very important in linear algebra because they help describe how vectors can be generated from other vectors. Many concepts in vector spaces are based on linear combinations, so that's why it's very important. They're also essential in solving systems of equations and understanding how vector spaces are formed. In simpler terms, linear combinations allows us to create a new vectors using existing vectors. Alright, so the next topic, that would be linearly dependent vectors. So vectors are linearly dependent if at least one vector can be expressed as a linear combination of the other vectors. This means that one vector depends on the others and does not contribute new information to the set. For example, if one vector can be formed by multiplying or adding other vectors together, then the vectors are linearly dependent. In simpler terms, there is redundancy among the vectors. Linearly dependent vectors are less useful because some vectors became unnecessary since that's why it became less useful. Since one vector can already be represented by the others, it does not add anything to the new vector space. Understanding dependence is important because it helps identify whether a set of vectors contains redundant information or not. Alright, on the other hand, vectors are linearly independent if none of the vectors can be expressed as a combination of others. This means each vector contributes unique information to the vector space. For example, the vectors angle bracket 1, 0, and the angle bracket 0, 1 are linearly independent because neither vector can be formed from the other. Linear independence is also very important because it ensures that every vector in the set has its own unique contribution. Linearly independent vectors are essential in forming bases and understanding the structure of vector spaces. So without linear independence, vectors may contain unnecessary or repeated information. The next concept would be the spanning set. So, a spanning set is a collection of vectors that can generate every vector in a vector space through the linear combinations. For example, the vectors angle bracket 1, 0, and angle bracket 0, one span the vector space R squared because every vector in two-dimensional space can be formed using combinations of those vectors. Spanning sets are also important because they describe the entire vector space and show how vectors can be generated. If a set of a vectors does not span a vector space, then there are some vectors in that space that cannot be represented using the set. Understanding spanning sets is important because they help determine whether vectors are sufficient to describe a vector space completely. Alright, for our next topic, that would be all about the basis. A basis is a set of vectors that satisfies two important conditions. First, the vectors must be linearly independent. Second, the vector must span the vector space. This means a basis provides complete coverage of the vector space without the redundancy. So the standard basis for R squared consists of the vector angle bracket 1, 0, and angle bracket 0, 1. Every vector in the space can be represented uniquely using these basic vectors. Basis is important because it simplifies vector representation and helps us understand the structure of vector space more clearly. So in linear algebra, finding a basis helps determine the essential vectors needed to describe a vector space completely. So our next topic, that would be the dimension. So the concept about dimension refers to the number of vectors in a basis of a vector space. So, for example, R squared has dimension 2 because its basis contains 2 vectors, while R cubed has dimension 3 because its basis contains 3 vectors. Dimension tells us the number of independent directions within a vector space, and higher dimensional spaces allow more complexity and are widely used in mathematics, computer science, machine learning, engineering, and data analysis. And take note that understanding dimension is important because it helps describe the size and structure of vector space. So, um, the for the applications of linear algebra, um, linear we have a lot of applications when it comes to this. The concepts of the dot product, angle between two vectors, cross product, linear combinations, linearly dependent vectors, Linearly independent vectors, spanning set, bases, and dimensions are all fundamental topics in linear algebra. And these concepts helps us understand vector spaces, relationships between vectors, and methods for solving mathematical problems. So they are also widely used in real-world applications such as engineering, physics, intelligence, computer graphics, economics, and data science. So linear algebra um, linear algebra is an important branch of mathematics because it provides tools for analyzing data, modeling systems, and understanding multi-dimensional relationship. So that's all. That concludes my discussion. Thank you very much for listening, and I hope that you've learned a lot or something valuable in our topic or discussion for today, especially in the concepts of the linear algebra. Thank you so much. Thank you so much for watching. And once again, I am teacher Jessa.